let's find the region, find area of the region that's bounded by these two functions. We'll say x is 2y squared plus 1 and x equals 2y plus 5. Now, I could easily solve the second one for y. I'd get y as a function of x. This, I hope you recognize, is a line. The graph is a line. Over here, if I were to solve for y squared, I'd have to take the square root, and then I'd have to do both the positive and negative square root. So I actually get two functions. So it's much better to leave it as x as a function of y as opposed to y as a function of x. But I hope many of you will recognize and know that this is the graph of a parabola. It's not opening upward or downward, though, since the y term is squared. It's opening, well, in this case, it's actually opening to the right because the coefficient in front of y squared is positive. But even if you don't know that completely, you can just plot some points and you can get the idea. So for this one here, what I can do is I could just plot some XY points. And what I would do is, of course, usually we plug in a value of x and get a value of y, right? Well, here we're going to plug in a value of y and get a value of x. So let's start with y equals 0, right? If I plug in y as 0, I get 2 times 0 plus 1, I get x is 1. So that point is 1, 0. Let's go ahead and start graphing this.
Also, just making sure, so for like problem 61 on the non-textbook homework, we're supposed to draw the graphs also, right?
Yeah, you definitely want to do that. And that, if you don't, I think it's going to be very hard to do the problems, especially this one. So because you really need to know which, you're integrating with respect to x, what's the top and what's the bottom. With respect to y, we're interested in the right and the left, and we'll explain why. So let's let every square, equal. So 1, 2, this would be 3, x equal 3, 6, 9, and so on, -3. And then we'll do 1, here will be 2, and so on, -2. Okay, so there's my graph. So I'm going to start plotting these points. X is 1, y is 0 would be right there. Okay, so there's 1 point. Then what if x is positive 1, or sorry, what if y is positive 1? 2 times 1 squared is 2 plus 1, I get 3. But the interesting thing, if you think about it, if y were -1, I square -1, I still get a positive 1. So 2 plus 1, I still get 3, right? Same y, two different y values give you same x value. But this is 3, 1, which is right here, and then 3, -1, which is down here. Okay. Well, we can do 2 and -2. If I square 2 or -2, I get 4. 2 times 4 is 8 plus 1, I get 9. So x is 9. Y is 2, x is 9, y is -2. Those are points. And you can kind of see already that this is a parabola. And you can plot some more points, obviously. But most of you know it's a parabola, and it's going to open to the right. And the quick way to know that is if the y term is squared and the coefficient is positive when you solve for x, it's opening to the right. If you solve for x and the y squared coefficient is negative, like it was -2y squared plus 1, it would be opening to the left. Okay. All right, so there's the graph of x equal 2y squared plus 1. And we could do the same thing then for the other one. And plot points. Really, if you know it's linear, though, you could solve for y. You can solve for y, and you can graph it with the slope and the y-intercept. But we'll just do the same thing here. If y is 0 here, I get x is 5. All right, so that's 5, 0. And then if I choose y is 1, now it's going to be different for -1. I was at y is 1, I get 2 plus 5, I get x is 7. And if y is -1, I get -2 plus 5, I get 3. So 7, 1, and 3, -1. Hey, we hit that same point. Okay, and you kind of see though the pattern. It's a linear function, and so notice the slope is going to be what? You're going up 1 over 2, vertical change of 1, horizontal change of 2 every time. In fact, this will be 9, 2 will be another point on that curve. It's a line with slope 1/2. So if you solve for y, you can almost see that you get 1/2 x minus 5/2. So there's that function there. Okay, so do we see the region bounded by these two curves? I'm going to lightly shade that in here. So what is the area of that region? Okay, so now, do you see if we attempt to integrate with respect to x, it's going to be problematic because between x equal 1 and x equal 3, the top function is the top part of this parabola, and the bottom function is the bottom half of the parabola. So you're going to have to solve, number one, you're going to have to solve for y, right? And you're going to have the positive root and the negative root. But after 3, from 3 all the way up to looks like 9 is that point of intersection, you've got the top function is the top half of the parabola, and the bottom function though is the line now. See that? So you'd have to have two separate integrals. Okay. However, if we integrate with respect to y, then notice we just have what we call a horizontally simple region. The rightmost function is the line, and the leftmost function is the parabola. So we always have rightmost function line, leftmost function parabola. So we'll be able to do this with one integral. And you can see from the graph what our limits are going to be. But in general, you should do the algebra, especially if it's not clear. The points of intersection can be easily found. Right? You solve the equation, which is what? Setting the, right, since they're both x equal, set both of them equal to each other. Here, x is 2y squared plus 1. Here, x is 2y plus 5. Solve this equation. I'll set it equal to 0 by subtracting 2y. Subtracting 5 from 1 gives me -4. So I got a quadratic equation. I'll factor out a 2 first, the greatest common factor. And then what's left over factors pretty easily, doesn't it? And so I can see that y is going to be -1 and 2. And so we know that's exactly what we saw here. When y is -1, right, we have that point of intersection. And when y is 2, we have that point of intersection. So we're integrating from -1 to 2, and it's always the left minus the right, which the way I've rotated around, you could say, you know, top minus the bottom, same thing in that sense, because the positive x-axis is going up. And so the final integral is going to be from -1 to 2, and this rightmost function is 2y plus 5. And the leftmost function is the parabola, x is 2y squared plus 1. And notice this is not dx, but dy, right? We're integrating with respect to y. Now you can simplify this before you do the integration, and I encourage you to do that. I got 2y, I got 5 minus 1. 5 minus 1 is 4, and then minus 2y squared. So that's what I'm integrating. The rest is, I hope, easy, if not a little tedious, but now you would find the antiderivative, evaluate at the upper limit, lower limit, subtract, and that would be your area. Okay, and that would be your area. So it's really not, that much different than if you're integrating with respect to X. You can, most of the functions we're going to give you in this case are going to be ones that you can sketch, fairly easily, and then set up the